Hi, everyone. Today I thought I would walk through the workflow that you could use for setting up your paper model to be cut, whether that's by hand or a digital cutting process. So the first step, not surprisingly, is to start with your sheared scaled fragment. So this is not yet scaled, meaning it is still, full scale. So if I dimension an edge, it's 12 feet. And just to confirm, if I go to another view, you can see that it is in fact the sheared version. So I'll go back to the top view. Once you have your fragment, you do need to scale this. It's a scale model, right? At ½ inch equals a foot. So to scale, you all know how to scale, but specifically to scale to ½ inch, you want to use the scale command and enter a particular scale factor. So for ½ inch, that scale factor would be 1/24. It's always a factor of 12. So a ¼ inch scale is 4 times 12. So it would be 1/48. An 1/8 inch scale would be 1/96, so on and so forth. So for ½ inch, we'll use a scale factor of 1/24. So I've already started the scale command. It says select objects, which I have. I hit enter. It's asking for a base point. So I'll just select the corner of the part. And then it's asking for a scale factor or reference point. So the scale factor is 1/24. And actually, yeah, there we go. Okay, it's scaled it way down. I have two other items that I will go ahead and scale as well. So they're all working the same place. And we can move those over there. Okay. So now we have something that is the scale of the model. So now if we get a dimension of this edge, instead of 12 feet, it is 6 inches. So that's perfect. Okay. Next step is to identify elements or parts within the fragment that you can manageably unroll or otherwise build. In most cases, you won't simply be able to unroll the entire thing in one fell swoop. So in this case, I will grab a small little wall piece over here and extract that from the larger part to start with. And the first thing I'm going to do is just unroll, okay? So using the unroll surface command, select curves, text dots, and points on polysurface to unroll. I'm not going to do that. I do want to draw attention, though, to the first variable, which is explode. Make sure that that's set to no. Normally, you don't want to explode the unroll. And I'm sure those of you that have started to work with unroll have found that you end up with hundreds of parts. So if I set this to yes and explode, it will do something like this. It's nice and tidy. It unrolls it in a line, but nothing's connected. And it would be maddening in some cases, in a lot of cases, it would be more difficult to kind of key each of these back together. Not always, but I would recommend trying to keep the unroll as a contiguous piece. So let's get rid of that. We'll go back, and this time we're going to unroll, and we're going to make sure explode is set to no. And then we end up this. So good news is it's a tighter piece, and everything is already registered to one edge. So everything kind of knows where it needs to go. Already we see a problem, though, because there's at least one surface that is overlapping with another. So that makes this an impossible piece to cut out of a flat sheet. So we're going to have to address that. Another thing I wanted to point out, one thing that will help you read these more easily is to make sure that the ISO curves are off. So you can just select any part, and then under properties, you can look under ISO curve density and turn off the ISO curves. So then it'll show us just the faces. But regardless, this is a problem. So let's get rid of, or let's just move this over to the side for now. So how do we address this? You have a number of options. You could remove surfaces that maybe won't be visible in the model, remove surfaces that you don't need, right? Even though they're part of the geometry, they may not need to exist in the physical model. They may make more sense to be cut separately. So in the case of this, I am going to, so one way to get around this is to explode the part, right? So first thing I'm going to do is explode, and then I am going to select the top surface and the bottom surface. I'm just going to turn on wireframe to get a better view of that, and I'll move them out of the way. Okay. I'll turn shaded back on. So we can address these separately. Now we have, in some ways, a more straightforward geometry. I'll reselect it and type join. So now they're joined together. Now, when I go to unroll this surface, I end up with something that is much more manageable. In fact, is possible, right? I can actually lay this out in a way that it could be cut and reassembled. And these, you know, aside from not being in the correct orientation, these are pretty easily cut as is. In fact, if this is a plan oblique, they are actually already oriented parallel to the XY plane. So you could just move those to 0 and cut those as well. Then you have your piece. Yet another option is a little more involved. I'll get rid of that. And I'll grab another copy of it. This is an interesting tool. It is called unjoin. So unjoin edge. So in this case, what we're going to do is be selective in the edges that don't stay attached during the unroll. So it allows you to kind of customize to a certain extent how the piece unrolls. So you do this simply by, you know, running the command and then selecting the edges that you don't want connected. So, you know, one way to do this is to select all but one edge of the top face here. And again, we could set this to wireframe and do the same thing for the series of the edges on the bottom surface. Okay. You can't see anything different, but when we move back to our unroll command, right, we get a different result. Okay. If you compare it to what we had before, which was impossible, what I did was I detached the edges on all but one edge of the top and bottom face so that I had control over where that unroll happened, right? So manageable on the left, not so manageable on the right. So again, that command is unjoin edge. And I think that'll be a useful tool for you guys to use in working through this. Okay. Another thing that came up, some questions that I've had already, is with, where is it? Okay, right here. Situations where, you know, when you were modeling your fragment, you maybe didn't have physically modeling it in mind. So there were objects stacked against objects, stacked against objects. So let's look at this as an example, right? Kind of a stair element, perhaps. Now, this is actually 3 different objects currently. And of course, you could unroll them individually. It's often makes sense to join them together though. And in this case, because they're all solids, I will use the Boolean union command, right? Now they are one. Simple enough. However, when we go to unroll, we end up with this kind of piece. And it's sort of hard to follow what's going on. And in fact, it treats each individual face as a surface. So it gets a little confused. What I would recommend doing is using a tool. It's called merge coplanar faces, right? There's merge all and there's just merge coplanar face. So if we select merge coplanar face, I can select a face and an adjacent face that is in the same plane, and it will merge them, right? And you can sort of continue to do that. Whoop. And I'll just keep going around. Now suddenly this is a much cleaner model. Certainly a cleaner model to unroll, right? So now, again, we go back to unroll. We end up with something like this when I turn off the ISO curves, right? And in particular, you can see the sort of either profile of that stair piece, okay? So another useful tool when you're working on moving your existing models to a place where they're more easily unrolled, more easily built, right? Okay. So I'll go ahead and get rid of those. Another challenge, let's move back to the top view for a moment, is that of the doubly curved surface. So this is a special case, right? If, there's my surface, it's doubly curved, it's a saddle, right? So what? Let's go ahead and unroll it. If you try to unroll a doubly curved surface, it will give you a mesh saying that it will produce inaccurate results. So it refuses to even try, right? Because it would effectively have to stretch the surface. So how do we get around this? Well, the first step would be to take the surface and actually convert it into a mesh. So often with Rhino, we work with surfaces. In this case, we're going to have to convert it into a different type of geometry. So if I go up to the mesh dropdown, we can say, create a mesh from a NURBS object. And, you can look at the detailed controls, or we can simply use, more or less polygons. I want to do as few as possible to start with, okay? And then I'll click preview to see what I'm getting. And that's what I get. Okay, let's try that. Okay, so I'm gonna slide the original NURBS surface out of the way, and we're left with the mesh. And the big difference is the mesh is made up of a series of faces, either triangles or quads, four-sided edges or four-sided faces that are planar, right? Those individual four-sided faces are not curved in any way. Each of them is flat. So this is a really good type of geometry to work with if you're moving into fabrication, especially full-scale fabrication. However, these are pretty small, right? So, and there's a lot of them. So what we can do is use a tool, another command called reduce mesh, and it will allow us to set a percentage or set a number of faces, right? So the current number of faces in this object it's 439. So we can tell it to reduce the number of faces to any number, You can also give it a percentage. So let's just say you want to reduce the number of faces by 90%. And if we preview that, we get this, right? And there's a trade-off because you lose information, but it also becomes much more manageable to actually cut and put back together. So, instead of doing 90%, maybe we go 80%, right? So you see, there's always a trade-off, So I'm actually we'll just keep it at 90 for now. Yeah, let's do that. Okay. So this seems manageable, right? We have a reasonable number of surfaces. The one thing that you have to keep in mind, though, is right now it's still a mesh. And unroll surface needs a surface. It won't work. So the last step is actually to convert the mesh back to NURBS. And fortunately, there is a command so titled, mesh to NURB. So you type that in, and immediately it will convert each of those faces that on the left-hand side here were meshes to surfaces. And you see it turns, it gives you the sort of ISO curve view. So we can turn that off. So they look similar. In fact, they look identical, really, except the one on the right, the NURBS can be unrolled. Okay. So I will get rid of these two, and we'll just take our newly created doubly curved surface, right? And let's try unrolling that. And there we go. Okay. So in this case, yeah, there is a challenge with an overlap. In fact, though, in this case, you probably could take this and explode it into a few different pieces manually, right? It's simple enough that you could do that. Okay. So let's go back to our original kind of sample part here. And we had 3 different versions of this unrolled. I'll just pick one. And once you have that, where do you go from there? I mean, I think you guys probably already know that you go into Make 2D, right? There are no hidden lines, so we don't have to worry about that. We do want to show the tangent edges to make sure we show the fold lines. And doesn't matter whether you group, I'm going to be ungrouping it, so I won't group it. And let's go ahead and see what that gives us. There we go. So from here, it may depend on which direction you're going. If you're going to print this on a laser printer and use that as a template to cut something out by hand, or whether you're going to go to a digital cutting tool like the laser cutter. So to start with, maybe let's figure out, okay, let's say we're going to lay this out in 11 by 17. So let's see if it even lays out on an 11 by 17 sheet, right? So there's the sheet. And we'll move this over, and conveniently it does. Okay. And we could pack this tighter, but let's just say, well, that looks good. And this is a pretty straightforward part, so wouldn't be too difficult to infer where the folds are, where the edges are. It's always nice, though, if you also include some fold lines or specify the fold lines. So I will actually select every edge that is actually a fold and not a cut. And then I'm going to just put that on a fold line layer. And actually what I'll do Let's see. One more time, and I will make sure that my line type is set to hidden, right? And I can keep the color the same. But now this gives us a really manageable thing that can be printed, and you have your fold lines, right? It's the beginning of your model kit. If you were going to set this up for the laser cutter, you could do it in a similar manner. You would just, however, want to make sure that you use color instead of line type. So if I wanted these interior lines, the fold lines, to be just engraved on the laser cutter, I would set them to red. Of course, they're not. And they make sure everything, they're not showing up red because the display color is overriding the layers. So I just selected everything and I want my display color to show as by layer. There we go. And the same thing with the line types. Just for this example, I want it to be by layer as well. Okay. And the visible curves, I'll set those to blue. Okay. So now I have, my blue line could be the cut line and the red line could be the engraved line on the laser cutter. And then you could save this and, bring it over to the lab and have at it. So there you go. Just a few tips on getting started with your sheared fragment model at 1/2 inch. Okay, good luck, everybody.